Hello, this is Mr. Stansbury. I'm going to take you through the notes on special right triangles, 45, 45, 90. That's a certain type of special right triangle. At the end of this, you should be able to say, I can describe the relationships between the side lengths of a 45, 45, 90 triangle, and I can apply relationships in special right triangles to solve problems. So let's do this. We're going to go jump straight into some examples to help us understand this thing here. So find the missing side or sides of the right triangle. Okay, so first one we have is we got a right triangle here, and we got these two sides are 7. So if you'll remember, since the two sides here are the same, that makes this an isosceles triangle. So that means that these angles across from these sides here have to be the same. So since we have 180 total degrees in a triangle, and we have already used 90, that leaves us with 90, and we know we got to split those evenly amongst these two, so 90 divided by 2. We know that both those angles here are 45 degrees. And if you'll notice 3 and 3, so we know both of those are 45. These are the same, so those are both 45, both 45. These are the special right triangles that have 45 degree, and 90 degree angles. Okay, so these are those special right triangles. Okay, now what we want to do is we're trying to figure out what this side over here is. Okay, so we can use a squared plus b squared equals c squared because it's a right triangle, right? So if you'll remember, the important one to remember is the c squared has to be the hypotenuse. So in this case here, we are going to have equals x squared. There's our hypotenuse. And then a and b are going to be the two 7s. So we're going to do 7 squared plus 7 squared equals x squared. So that's 49 plus 49 equals x squared, which gives us 90, not 6, but 98 is x squared. So we square root both sides, and we get that x is, let's see, so second square root 98, and we get 7 root 2. Now, I'm going to actually, instead of putting this into a decimal, I'm going to leave that as 7 root 2 because this is going to help us see something that's going on. Okay? So this here is going to be 7 root 2. It's going to be that missing side. Okay? So let's try this one here. So we'll do the same idea, and we're going to do 3 squared. The two legs are both 3, so 3 squared plus 3 squared equals c squared. So that's going to be 9 plus 9 is c squared, which is 18. Then we square root both sides, and we get that c. When you do square root of 18, you get 3 root 2. Okay, so 3 root 2. Now, let's take a look at these two answers. So we started, these two sides here were 7, and we found that this hypotenuse is 7 root 2. Okay, now these two sides are 3, and look, interesting, this hypotenuse here is 3 root 2. Okay, so notice we have this side here, and then this side here is just going to be 7 times the square root of 2. These two sides are 3, that's 3 square root 2. So if these two sides here are 13, guess what this is going to be up here? 13 square root 2. If these are both 27, these are going to be 27 square root. This one's going to be 27 square root 2. Okay? So then now what we know is if we've got a 45, 45, 90, the ratios are going to be whatever these are. So these sides here, let's just make it as simple as possible. Let's say that both those sides are 1, so it would be 1 to 1. And then this last side is going to be whatever the across from the 90 degree side here is going to be whatever these sides here are times the square root of 2. So that's going to be 1, 1, and then 1 root 2, or just simplified down to root 2. So there's our handy dandy rules here. Okay, so let's use that info there to come up with, find these last 4 examples. But before we do these last 4 examples, let's take a little comedy break.
You said that to me.
All right. Let's take a look at these here. So we have, this one here, we have our 45, 45, 90, our isosceles triangle, but we only get one side. They give us the hypotenuse. So now we have the hypotenuse. We got to figure out what the two legs are, right? So let's do this. We know that these two are like a squared, and these are going to be a and b, but since they're the same, let's do this. Let's call them a and a. So we'll call this a squared plus a squared equals 11 root 2 squared. So there's a squared plus b squared equals c squared here. Okay, so a squared plus a squared is 2a squared. And then that's going to equal 11 root 2 squared. So let's figure that out here. So we got 11. Let's do this. Let's do parentheses. 11 root 2. Oops. Let's get that all figured out here. Delete that. Move the arrow over. Now we got this. There we go. 11 root 2 squared. Push equals, and we get 242. So this equals 242. Now we want to divide both sides by 2. And we get that a squared equals 242. So that's going to be 121 if we divide that by 2. So we square root both sides, and guess what the square root of 121 is? That would be 11. So look, this is 11 root 2. These are both going to be 11s. Okay, let's try the same thing with this. Make sure that that works out the same way. So let's call this a and a again, since they're both the same length. So we got a squared plus a squared equals 5 root 2 squared. Okay, so we bust out our calculator. 5 square root 2, go over and then close, there we go, squared, gives us 50. So we have a squared plus a squared is 2a squareds equals 50. Divide both sides by 2, and we get that a squared equals 25. So we square root both of those, and we get that a is 5. So look, that's 5. And this here is also 5. So look, this was 5 root 2, and those just turned into 5s. All right? So we probably could have done that with this ratio here, knowing that this is 5 root 2, that's just going to be 5 and 5. This is 11 root 2, that's 11 and 11. Now, what do we do here when we've got 15? There's no root on there. So let's try our a squared, b squared, and c squared again and see what happens. So we got a squared plus a squared equals 15 squared, right? So that's 2a squareds equals 15 squared, I believe, is 225. Right, that's just, yep, it's going to be 225, but we're going to need this number here in a second. So we take 225, we got to divide both sides by 2, and we get a squared equals, divide that by 2, and we get 112.5. Now we want to square root both of those, and we get that a equals, so we square root our answer. We get 10.606. So we get 10.6066 for A, which is not really super helpful for what we have here. That doesn't make our little rule easier. So let's look at it this way. On this hypotenuse, we had 5 root 2. To get rid of that root 2, basically we took this 5 root 2 and we divided it by root 2 to get down to 5, right? So let's try that same idea here. So let's take 15 and divide it by root 2, and that's going to be what these two sides are here, right? Now the thing is, we can't have a root in the denominator, so what we have to do is we have to multiply by root 2 over root 2. The reason why we do that is, again, it's whatever is on the denominator, this root here, we want to multiply it by that exact same thing, because if you'll notice when we do that, we get on the top we have 15 root 2, but then square root 2 times square root 2 is the square root of 4, which is really 15 root 2 over square root of 4 is 2. So then that 15 root 2 divided by 2, if we plug that into our calculator, guess what we're going to get? 10.606. So let's just show that 15 times the square root of 2 gives us 15 root 2, and then now we divide that by 2, and we get that crazy looking thing here, which turns into 10.6066. Okay, so what we want to do if we have the hypotenuse is just divide it by root 2 and then simplify instead of plugging it all in and getting a decimal answer here, right? So this 10 here, then we would take 10, divide it by root 2. Again, we can't have a root in the denominator, so we multiply by root 2 over root 2. And then on the top we have 10 root 2. Root 2 times root 2 is root 4. And we get 10 root 2. Square root of 4 is 2. So it's 10 root 2 over 2, but that actually simplifies. 10 over 2 simplifies to 5 root 2. So that's an even better answer here. 5 root 2, 5 root 2. Okay, and then this one over here, if you remember, is 15 root 2 over 2 for these A's. 15 root 2 over 2 for both this side and this side here. Okay? All right, that's all there is for special right triangles 45, 45, 90. If you have any further questions, please feel free to ask. Thanks.